Hey folks, welcome to another Geometry Nodes tutorial. This one is kindly sponsored by Skillshare. More on them later on. This video is following a request from Genesis 2303. So thanks so much for putting in a request here, asking about the curve map node. So we're going to do this, that you can see this on screen. Basically just these vases. We've got them scooching around on a sphere and they're interpolating, they're lerping between different shapes, kind of like shape keys, but we're going to do it entirely through geometry nodes. So we're going to use the curve map node in Blender 3.0. So if you're using 2.93, if you want to follow along with this tutorial, you're just going to need to grab one of the experimental builds. Let's go and jump into geometry nodes. This whole thing essentially is done in geometry nodes. There's 3 elements to get everything lerping correctly, and then all of the objects changing properly, and then also getting them moving around the ball. So there's 3 stages, and we're just going to work through them. There's 2 ways that we could create a vase. We could create a line, and then we could sweep it using the curve nodes. So you could generate your line and then do like a mesh to curve and then curve to mesh using that line you've made as the profile, putting it around a circle curve. In this case, we're not going to do that. We're just going to do it with a cylinder and change the radius, basically scale the radius. And the reason we're doing this is because the question was specifically about making chess pieces. And if you do it in the sweep method, you're only going to be able really to do cylindrical things or things which have that swept profile, whereas if you're making chess pieces, you also have knights, and knights are never symmetrical or never revolved anyway. So to be able to create the face and have meaningful attributes, you really need to do the cylinder. So this is why we're doing the cylinder now, just to make it easier for this to be transferable knowledge to other projects. Here we go. So I've got my cylinder. First things first, let's take the bottom of our cylinder up to the 0 position. So move it up in the z-axis 1 meter. I'm going to delete the top face, delete faces, and I'm going to add loop cuts in here. So this is because we need enough topology for us to get a proper shape going on. And let's just make this high. I'm going to give it 100 cuts, and then I can just right click to release that. So you've got this nice topology in here. You have an open top, and we're working on something which has a radius of 1 meter. So I'm not going to change that radius because it's a value of 1. It makes it very easy for us to multiply stuff by it and just end up with our desired value. Rename our object to vase. I'm just going to rename the collection to vases. So we have a 0 to 1 range here. Let's add a new geometry nodes modifier, and let's take an attribute separate XYZ, and we're going to take the position vector, and we're going to extract the Z position here. And we're just going to call this one fac, just because it's a 0 to 1 value essentially. So once we have our factor, we can do some curve mapping with it. But if we have a look at the curve map node, so Shift A, attribute curve map, we're going to see that this has, we can see like a crosshair in the middle. And this is because the default clipping range of this is -1 to 1. Now you could change this and then go and, zoom in or out on the little graph here, but it's easier really just to do maths outside. Leave this as -1 to 1, and then we're going to just grab a map range node, take our factor, and I'm actually going to change this to a new attribute called shape, so that I still have that fac value, that 0 to 1, just in case I need it. And we're going to take the shape value here from 0 to 1 on the fac to an output range of -1 to +1. So now this fits our curve map node, just to make that a bit easier. And then we're going to take our shape, and this is going to be the attribute that we work with. Now after this, I'm just going to call this one vase1. So we're outputting vase1, and then we want to do something with this value. So we want to take this value and scale the radius. So for us to do this, we're going to need to use some vector math. We're going to want to take the current positions as the input and output, because we're actually changing the position and we want to write that to the position. And we want to multiply this by some attribute. Now, if we were to just multiply it by vase1 at this point, then the Z position is also being multiplied. And that's why we get this kind of weirdness going on. It's going down. We don't want it to affect the Z position, so only in X and Y. So we're going to use an attribute combine XYZ. Drag this down here. Going to take an attribute in X and Y, and let's use vase1 in these two. And then we're going to write to vase1 as well. And then our Z is just going to be 1. So there we go. Now we have this nice range from -1 to 1. So again, I'm going to want to change this. So let's remap afterwards. So we're going to use another attribute map range. Take vase1 in the attribute and the result. Go from -1 to 1 in this case. And the output range here, we're going to go from 0, because we want to be able to hit 0. We want to be able to scale down to nothing if we want. And this max value becomes essentially the radius scale that we end up with. So let's just set this to 0.5 for now. I'm going to make a bit more space here because this curve map node, we can increase the size of a little bit. Cool. So now what we have is a vase, and we can change the shape entirely with this curve map because we're just scaling the radius. So let's go ahead and make a few little shapes here. Now at this point, once you have this set up, it's actually very simple to start working with it. The only complexity then comes when you want to start lerping between stuff, and how do you actually do that? So I'm going to bring in the radius a little bit further here with that map range, do a little bit more scaling. If you need a sharp corner, this drop down menu here on the map range, on the curve mapper, we can just change this to vector handle, and now we get a sharp corner there. If you want to move multiple points at the same time, you can click them and shift click, and this is a little bit weird. My gut feeling is that you're not actually supposed to be able to move multiple points at the same time, but you can. So if I click one and then I shift click another, and then I think, okay, I want to move these two, and then I still holding down shift, right? If I click on one of them again and drag, it deselects the one that you click on. So you have to be ready to drag on the click of the last one, right? So if I shift click on here, then I can drag those two. Or if I click on another one, if I click and then keep clicking, so I'm dragging, I can move that like that. And I'm just holding shift there. If I was to let go of shift, then I would just drag one. So that is our first little vase. Let's go and create another one. So I'm going to come out here. I'm going to frame these up, and I'm going to make my multiply at the end. So these three nodes, the attribute curve map, map range, and combine, Control J, these are what controls each one of our shapes. That's vase 1. I'm going to make 3. I'm going to make 3 of them this time. So Shift D on there. Make sure that you're doing this in series. And this one's going to be vase 2. And just on our curve map node, we're going to be writing to vase 2. So we want to be using new attributes for this, for vase 2. And just everywhere you've used vase 1, change that to vase 2. And I will change that as well on that multiply. So now I can make something which is a bit more angular. So let's take one of these, and I'm going to change this to a vector handle. And I might also create a little base for it. And we're going to change this one to a vector handle as well. And I'll add another one, change this to a vector handle. Something like this. And I might do another little dip in the middle. No, I will remove that. So if you want to remove a handle, see I've got one there, I can just click the X while it's selected. So on this bit here, I'm going to create 2 points, make them both vector handles, and then I'm going to put a normal curve handle in between them, so vector, and I'll just pull that down in the middle there. Great, so you can see this is why we added so many loop cuts, because it's important that we're able to actually create some inwards there. If I come onto my object data properties, which are behind my head, so just on this green triangle here, we can go down to the normals and then click auto smooth, and that's going to give us our edges back. You can change the smoothing angle on that. Cool, so that'll do for our angular one, and let's give ourselves a third one. So this one we're going to make a little bit bigger. So let's join these up like so. I'm using the node wrangler with Alt, right click and drag to get that connection. This time we're making vase number 3, and I'm just Control Ving those into position. So I know we're working through quite quickly here, so there's not really a huge amount to say about these steps. We're just repeating what we did. There we go. Maybe I'll do this one as actually just like a real big round one. There we go. Something like that, and I might make it a little bit bigger. So I've got 3 different shapes, 3 different profiles going on, and I want to be able to mix between them. At the moment, we're just multiplying by one at a time, but I need to come up with a way, basically, to create a lerp. So to make sure that I'm working with attributes, pick an attribute fill node and set this to be type. So I'm just creating a new attribute called type and giving it a 0 value, just a float value. And we're going to change this in a sec as well. So the next thing to do is actually multiply this by, in this case, 2. So it's the number of profiles that you have minus 1, because essentially we have this one, which is 0, and then we have 1, and then we have 2. So at the moment, if we think of something like a noise texture being a range of 0 to 1, then that will give us a lerp between 2 of these shapes, and we want to go between 3, so we need a value between 0 and 2. Let's take our type value. We're going to just drop it into our regular attribute math node. We're going to set this to be multiply, and then we're going to output to picker. So I don't want to change this type value because we're also going to need it in shaders, because we're going to change the color of these as they change type. So let's just set that to be picker, and we're going to be multiplying by a float value 2. So if you have 8 of these different profiles, then you'd be multiplying this by 7. However many profiles you have, subtract 1, that is the value. And then what we want to do is we're going to use map ranges in this case actually. I know it's slightly more computationally heavier than just using subtract, but the way that attribute mix nodes work in geometry nodes is a little bit different to shaders, because in shaders, if you do a mix, the factor is clamped between 0 and 1, whereas in geometry nodes, if you put in a mix value of 2, then it will actually lerp outside the data set to give you a new value that's kind of beyond your existing values. So that might be useful in some cases, but for what we want to do, where we're going between multiple shapes, and we need to have multiple sequential mixes, we need to be clamping the factor ourselves. I've got a mix here, and I'm going to be mixing between 2 of these vases. So I'm going to mix between vase 1 and vase 2 in here. So vase 1, vase 2, and I'm going to output this one just to vase, so just with no number. And then I'm going to do another mix immediately after, which is going between vase, the output from the first one, and vase 3. And we're going to write to vase again. And then finally, our vector multiply is just going to be vase. You can see that we can go from the first profile to the second profile and to the third profile. So there we go. So we need to have values between 0 and 1, 1 and 2, and map them to these 2 factors. Let's take an attribute map range, and we're going to go from picker to, let's write this to picker 1. There we go. This is the one that we're going to use in this first attribute mix. So let's change the factor to an attribute, take picker 1. This is the value in here. And we're going from 0 to 1, outputting 0 to 1. And to make sure that things kind of hold their shape and then they lerp to the next one, we want this to be a bit of an S-curve. So rather than them just being like this, where you have points, point, point, as we move in between these, it's going to basically not really stop on any of these. So if we were to have an S-curve between each one, then it's going to be more like this, right? And it's going to feel like it's holding a little bit better on each one of our shapes. We can do this with a map range, go from linear to smoother step, and that's it. That's all you have to do. Now we're going to take another map range. This time we're going from picker, because it's our value, and we're going to write picker 2. And we're going to go from a value of 1 to 2 in our inputs, and we're outputting 0 to 1, because this is our factor range. And again, smoother step. The smoother step clamps, so we're all good there. Take this mix, take our factor to an attribute, and we'll set this to picker 2. Now you can see if we change our fill value here, which is affecting the type, which becomes the picker, we can go up to 2, and then up to 3. There we go. So vase 1, vase 2, vase 3 there on one slider. Okay, next step is going to be making this affected by noise. Actually, before we do that, let's turn this into something which can control the shader as well. So I'm going to create a new shader, jump into Eevee, and let's do a real quick shader here. Now the cylinder is UV unwrapped. So if we were to take a UV map node, you can see that we've got a seam and the circle on the bottom. And if we take a converter, separate XYZ, our Y values, if I use a map range node on here, they start at 0.5. So 0.5 to 1 is like the range of the side there on your UV map. And this means that you can do some maths to create some lines and things. So if we were to say subtract, then we get this line, and then I can absolute that to make it go in both directions. So we can do something like this. And now if you want to space that out and give yourself multiple lines, then we can subtract again, and then we can absolute again. And there you go. Now you have a couple of lines. And then I can also just put a minimum on here and take our original one as well. So now I have 3 lines. There we go. Great. And I might just do this again on another position with another minimum, join that up like this. And this time we're going to go up to the top. So here we go. I know we're running through this fairly quickly. There's quite a lot of content out there about shaders, quite a lot of content on this channel about shaders, so I don't want to cover it too deeply here, just while we're doing the geometry nodes tutorial. Let's grab another map range node, set this to smoother step, and we're going to go from 0 to 0.1, maybe even a bit lower, 0.02, yeah, something like that. And if we look at our principled node, let's give this a color. I'm going to go with that nice blue color, and I'm going to use another math node, set to greater than. Set this to, actually let's go with less than 1 on there. And we can see that actually those lines are really big, so 0.01 should be a bit better. Taking a mix RGB, and we're going to go from our color, and our second color is going to be sort of gold color, make it nice and bright. Take that into the color. This value is going to be 0 and 1, so we can plug this directly into the metallic. We can use a map range to take these values from 0 and 1 into our roughness. We want to have about 0.3, 0.4 for this part, and then 0 for our shiny gold. And then this map range part before, where we have the smoother step, we can plug this through a bump map bump node like so, plug it into the height. Remember that the distance on a bump node is in meters. We definitely don't want to have a meter depth here. We want this to be like 0.05, something like that. So that's 5 millimeters. That's probably fine actually. The blue is fine, but I want to have 3 colors. We have 3 different vases. Let's grab 3 different colors on here. I only actually need 2 mixes for that. So plug this in like so. So with a mix value of 0, we have our orange. And then with 1, we're going to have a second color. Let's make this a nice green color. And then if we have a value of 2, so our second mix goes up, then we're going to have a different color. Let's just make this nice and white here. There we go. 3 different colors on a single slider again. And we're going to match the lerp with our map range node. Alrighty then, so I want to get this type value from geometry nodes into shaders, and specifically into Eevee. If you've tried this before and you've gone input, attribute, type, because this is, same name, so it should be able to view this, right? Well, that's not unfortunately how it works. If we go into cycles, then you'll see that actually we can read this value. You can see that there. That's changing as I change it in geometry nodes. But in Eevee, this is not supported. So we need to find a different way. Fortunately, it's actually really easy. So I'm just going to scooch over to the end here. Just make sure I'm not cluttering anything up. And I'm going to add an attribute convert. Drop that on there. Make a bit of space here. So I've got attribute convert and I'm taking the type attribute. And we're going to write it to col. Now you can call this anything. But the important part is that you have a vertex color layer. So vertex colors with the same name. The default name is col with a capital C. So I'm just using col with a capital C in my convert node. So now you can see that we're actually converting that properly to a color layer. We're writing it to a color layer which we can now read in shaders. So back in shaderland, we can take this value. We're going to multiply it by 2, and that's going to give us our 0 to 1, 1 to 2. And once again, we're going to use map ranges. So take 0 to 1 to 0 to 1. We're going to use smoother step instead of linear again. This goes into fact number 1, and we're going to control shift D, grab ourselves another one. This time we're going 1 to 2. This one goes into mix number 2. I can output my shader, and if I look at my type here, we have blue, a green, and then a white. So now we have 3 actual different vases. So I'm going to push away my materials for now. We don't need them again. Okay, vases are done now. Let's have a look at Skillshare. Skillshare is an online learning community with literally thousands of classes on a whole range of topics from illustration to creative writing, fine art, product design, all sorts of things like that. But they also cover the side that most creatives seem to avoid, which is business. So there's all sorts of classes available to us as professionals who are trying to get ahead in this creative world. One that I'm really excited about at the moment are these ones by Remington Markham. This is Southern Shoddy 3D, if you follow him on other platforms. So he does amazing Blender stuff, and usually it's Blender beginner stuff, right? And I've been using Blender for, getting on 13, 14 years now, but I haven't done a whole lot of animation, and some of the projects I'm working on this year need more animation skill. I need to learn more about rigging and more about character animation. So I've been taking this one, the Your First 3D Animation, and honestly, I was a little bit skeptical about how much I would learn, but I thought it was important for me to hit the basics again. And it's so good. It's so good. It covers all of the basics in a really well thought out, thorough way. And it covers like the dope sheet and the graph editor, and even covering little basic things like using Blender's interface and what a keyframe is. And all of the project files are included along with the course. So you can get right into working along with him through the animation process and really understand these fundamental principles of animation. Another thing that's really great about taking classes through Skillshare is that there's no interruptions. You're there to take the class. There's no adverts. There's nothing to distract you from learning just the way you want to learn. So if this sounds like something you would be interested in, then check the link down in the description, and also the pinned comment will have it. The first 1,000 of my subscribers to click that link will be able to get Skillshare for a full month, as opposed to the regular 14 days. So if you want that longer Skillshare premium period, then you can get the free month down on the link down in the description below. Okay, welcome back. So we are going to be taking our vase and we want to make a few of them. Just before I start duplicating things, I'm going to make sure I've added a solidify. Just make sure I have that thickness. Now obviously this vase is much bigger than a real size vase. You can always scale these afterwards, of course. I'm just leaving this as is for convenience. So I'm going to give that a bit of thickness. So that's fine. And back in geometry nodes, the way that we can make sure that everything is changing procedurally is by driving the type with a noise texture. So what we can do here is have an attribute sample texture, and I'm going to give this a new texture. Let's call this type. Now, if I was to just put in position in here, an output to type, and then let's give this a new clouds texture. Okay, you can kind of see the problem. We're going to run into this issue where we just don't have what we want. This is working per vertex, which is, I mean, it's great that we can see that our shader's working, but not so great because it looks terrible. So what we want to do, we want this to be a flat value, a constant value for the whole thing. And I want this to be, you know, per vase. If we have 10 vases, then I want this value to be judged on each of those 10 individually, which means two things. First of all, it means that we want to be driving this from the position of the vase instead of the position of the vertices. And it also means that we want to be driving this from outside the node tree, because if it's inside the node tree, then it's going to be the same for all of them. So if we take an input object info node, this allows us to pull the location of an object. Make sure you leave it on original because we don't want this to be relative to the object, because the object relative to the object is always going to be 0. So leave it on original, and we're going to use this with an attribute fill node. So let's change from float to vector, and I'm going to change this to mapping. So we're creating a mapping attribute based on the location of an object, and this attribute can then be used, this mapping attribute can then be used in our sample texture. The object in question is vase. So if I pick that, then you can see as I move this around, it changes. But if I was to have two of them, moving one doesn't change it, but moving the other one changes both. So that's what I mean about pulling it out onto the modifier. So let's just add another group input node, grab one of these, and I'm just going to plug in to that object there. So if I delete that second one there, if I now duplicate this, you can see that it is changing based on vase number 1. And this one, this original one, is still looking at vase. If I duplicate that again, because it's in the modifier, it detects that it's been duplicated, so it's going to reference a new version. So this is something that we saw in the bridge tutorial. If you've not watched that, then I recommend it. Essentially, anything which is on the front, any objects which are picked, if they get duplicated with the node tree, then it will reference that new one. If it's referencing a different object which is not being duplicated, then it will not update that because it will, it'll know that it's not needing to pull a new object. So very useful. So this is great. What you would notice though, if you had a bunch of these in different places, is that most of them kind of sit in the middle on this green one. So what we want to do here is tweak our type attribute. I'm just going to delete everyone but the original in here, just to keep things neat for now. So just after our sample texture, let's throw in a color ramp as well, just to make sure that we're getting, a little bit more time at both ends. So I'm just going to give 0.1 for our black flag, 0.9 for the white flag, and we're going to just take type, Control C, Control V, and now it's going to spend a little bit more time on the others as well. So you can see it feels a little bit more balanced. There's probably still going to be more green than anything else just because it's a noise texture. You could, if you wanted, change this from, change the noise basis to something like cell noise, and then you would notice that it's going to step, which might be what you want. But in my case, I'd just like to have Perlin. I'll go with one of the different kinds here maybe, so you can always play with those as well. How do we get them to move independently and be looped, right? If we have a 250 frame animation, how do we get this to loop nicely? Well, there's a pretty easy way to do it. So make sure that we're saving, Shift A, add a mesh, add a plane. Doesn't really matter what we use here. So the way that we're going to be moving these is by parenting them to an object, not just to an object, to the vertices of an object. Because if I just parent this to the object and then I use geometry nodes to move it, then all that's going to happen is the mesh is going to move, but the object is not going to move. So we want to actually parent this to the vertices. The way that you do this is by select the object, shift click on my plane object, tap into edit mode, select a vertex, and then press Ctrl P. This is going to say make vertex parent. And now when I do this, you can see that we have the dotted line going to the vertex. And if I change this, even in edit mode, that is going to follow that vertex. So now all I have to do, I'm going to move the plane out of that collection, is I can just duplicate these. So I've already made that parent connection. So I can just make a bunch of these in different places, making sure that we're sampling different parts of the texture as we go here. You're still going to notice that we're using mostly green, which is our central one. So what I'm going to do is I'm going to pull this in slightly by changing it from linear to ease, and that's going to give me a little bit more at both ends. So there we go. So now I've got a few more colors, and as I move these around, you can see that they change. So that's great. Now let's animate this. So we're going to use geometry nodes again. So add a new geometry node. So I'll call this one plane, just so I know what's going on when I look at my drop down. And a really easy way to make things loop is by rotating them, which might sound really obvious, but I'm just going to use an attribute vector rotate. We're going to rotate around the z-axis. I'm going to be adjusting my center. So we're going to need the position. So these are the attributes that we use, the input and output. And now if I rotate this, you can see everything is following along nicely with that. And if I was to move my X value, you can see that we're rotating at the bigger radius. It's offset to the side, but that doesn't actually really matter. So let's do a couple of things. Let's make this easier to use from the modifier, because I don't always want to be in this node tree. Let's first of all get a vector combine x, y, z, and we're just going to take our x value. If I press N, go to the group, here we go, this is our radius. Right, and this is going to be important because it's going to be a big factor in the speed. And then we want to work out how to make our loop. So the way that we can make things loop is with a bit of maths. So this input expects between 0 and 2 pi radians, 6.57 or something. We can just write tau to give this, so we get 6.28. We can just use tau instead there. So everything needs to be a fraction of 2 pi, and each frame as we go along needs to get progressively closer to 2 pi until frame 250 is at 2 pi. And take our driver frame, so let's type in hash, and then frame, just like that. And this is, you're going to see that if I play the timeline, that increases. And we're going to divide the frame by the total frames, which we can see over here is 250. There we go. So now this is outputting a fraction of how long our animation is. And then we can just multiply this by 2 pi, because on the last frame, this will be a value of 1, and on the first frame, it will be a value of 0. If you don't want to remember this maths, then you can just do this with a map range as well. So let's multiply this by tau, T-A-U. And I know it's confusing because the angle as we use it is in degrees, but any socket is always read as being radians. So now if I press play, this is going to come around and we're going to reach 250 just as we pass that start point there. Now I can increase the radius and it's going to appear to move faster just because it's further out, but it's still taking the same amount of time. But you can see it's going to make our vases change quicker. So something like that is fine. I'm going to make a new collection, grab them both, move them in. I'm just going to call this one hidden and I'm going to hide it just like that. We're no longer working on our vases. Vases are done. We're now going to work on the effect of making things slide around on a ball. So this is another fun little challenge for us. Let's add a UV sphere. I like UV spheres just because they have good UV maps. So if you want to texture them, it's a little bit easier. I'm going to subdivide it just to give me a nice smooth outline. And I'm going to add geometry nodes. So I'm going to rename this one as well to ball. Now, pretty standard, point instance and point distribute. Let's create these points, instance the collection vases and turn off whole collection. At the moment, these are all changing nicely. If I press play on that, let's add an attribute randomize for the scale. And I'm going to make them a bit smaller, 0.4 to 0.6, just so I can fit a few more on. Now, it doesn't matter about intersections because when we move these around, they're going to intersect like crazy. We still have more greens than anything else, so it's up to you, but you might want to just tweak that. So at the moment, all we're doing is changing color and lerping between different shapes, but we want these to slide around our ball. So what we need to do is a little bit of linear light. It's been a long time since we've done linear light on this channel, so let's add some now. We're going to jump in here with a sample texture, create a new one. Let's call this one clouds, not very original. And let's change the type to clouds here. And let's leave this as it is for now. Move things over. We're going to be creating a new mapping attribute because we want this to be animated. So let's just type in mapping in here. We haven't made it yet, so let's add a vector math node. And we're just going to do the exact same math essentially as we did for the vector rotate node. In this case, we're just going to do the entire thing with a driver. It's a lot simpler if you know what you're doing, So maybe grab a pencil and paper and just jot down the formula for what we're about to write in here. It's very useful. So we're just going to take a vector add, and we're going to be taking our position, and we're going to be adding a vector to it, which we're going to define with drivers, and we're going to write this out to mapping. In X, what we can do is type in hash, because we want a driver, sign, because we're going to be creating a circle. We're literally looping it by moving this in a circle, so that's how we do this. So it's exactly the same maths. We just take frame, which calls the current frame, divided by the end frame, so 250, and then multiply with an asterisk by tau. So that's all it is, just sign, open brackets, frame by 250, asterisk, tau, and then close the brackets. I know there's going to be quite a few people commenting saying that this doesn't work. Close your brackets. So let's do this again, cos, drop that in here. So for X we did sign, for Y we're going to do cos, just like that. And now what we have is an animated circle on here. Now we're not going to see it yet because we're not doing anything with this clouds texture. So let's write it to the result clouds, and we're going to do some linear light. So attribute mix, drop this on here. Going to change from mix over to linear light, and let's give it a full factor. Position, we're going to be taking our position. We're also going to write to the position, and this attribute in the middle is going to be clouds. There we go. So you can see that as we increase that, we get this movement. And the reason I love linear light is because it goes positive and negative. So if you have a value of 1, it will add 1. If you have a value of 0, it will subtract 1. That's great. And at 0.5, it will do nothing. So when you're working with noise, linear light is very useful. You'll notice that these only go in that like positive XY direction. And if we change our texture from grayscale to color, now they go in all directions. And if I play this, you'll see they're going crazy. So let's turn off our depth, that'll smooth it out. And then let's increase the size here, and that'll slow it down. Maybe go up to 3. So again, if I had higher depth on here, you can see they're just jiggling. So we want nice, smooth, slow movements. Now, these are not on our sphere anymore. Let's make them be on the sphere. There's 2 ways that you can do this. If you are using a surface which is kind of arbitrarily curved and displaced, then you would want to use the raycast node. I will do a video on the raycast in the future because it's very, very useful. But for now, because we're just doing a sphere, what we can do is normalize the vector. So when you normalize a vector, all you're doing is you're changing the magnitude of it to 1. So right now, some of these have a magnitude greater than 1, which is why they're over here. Some of them are less than 1. What we want to do is just take an attribute, vector math, drop it onto the noodle, change from add to normalize. And you can see we don't have any B attributes in here. We just have an A, Control C, and we can paste this into our position and result, to A and result. So now if I play, you can see that these are actually going around the sphere. But let's bring back the sphere so you can see that. So I'm pressing Control Shift and then right click on my first one, drag it over to the point instance, and there we go, something like that. So now if I play this, you can see that they're on the surface, but they're not pointing in the right direction. So again, if you're using an arbitrary surface, I would recommend that you do an attribute transfer, so you can calculate the normal on your surface and then do an attribute transfer and transfer that to your points and then do what we're about to do. But if you're using a sphere like I am, then we can use a point, align rotation to vector. You can see everything's dropped over. So we're going to be taking the Z axis of our vases and we're going to be aligning it to the attribute position. And this is because with a sphere centered at 0, 0, 0, the position at any point is literally the vector away from 0, 0, 0. So that means that we can get this really great surface where everything just kind of slides around and looks like it's kind of zooming around the surface. So after this point, it's just kind of tweaking it. You know, I think these vases change too quickly, and that's to do with the speed of our plane going around and moving these, and also to do with the size of the texture that is changing them, the type texture. Because I can see that these aren't actually moving that quickly. I'm going to go into one of the vases, grab its texture in here, the type texture. We have a size of 2, let's go up to 4. And now if I play again, it seems to be moving a little bit slower there. I would recommend, by the way, if you are making changes, especially in a file like this where you are instancing geometry nodes objects, first of all, save constantly. And secondly, every time you want to make a change, pause. Don't play the animation while you're trying to mess around with attributes because it's quite likely that you will just crash. So there we go. So I think things are moving a little bit better now. I'm going to go back to hiding that, and I want to add a camera, and I'm going to make it have a slightly higher focal length as well, maybe around 30, just so I can get things zooming past. Spheres, Eevee spheres especially really good because you can just slap a texture on them. As long as it's seamless, you're good. So let's go into the shader editor and just real quick add a shader for this ball. I'm going to just use a PBR texture, grab something like this, which is just a nice picnic texture, and I want to scale it up. So Control T on here, I have the node wrangler, so it's going to be the principled setup, and then I want to scale this up like so. I want this obviously to be in whole numbers because then the seamlessness will work. So you can see when it's not whole, not seamless. Make that something like that, and there it is. So we covered quite a few things in here, using the curve map node to be able to kind of arbitrarily create shapes. When they're cylindrical like this, I've mentioned it before, but you can do it either by creating a cylinder, how we did, or by doing the trick using a line and then sweeping it as a curve. But either way, it's just a really nice way to work, actually. I mean, if you see, have a look back at the video that I did from November. It's very similar. I made a chess set. The only difference is that shaders are much more parallel, so I was able to kind of switch between stuff. But the kind of the workflow is essentially the same. You know, you can take your object and scale it either in the radius or by creating a shape and sweeping it, and just, yeah, have complete control just using the curve map node. So hopefully this was interesting. This effect as well, getting them to slide around on the ball. I feel like somebody's going to ask, you cannot make this work without having intersections. You might be able to do some kind of like path mapping thing across the surface with like animation nodes or sphere shock and have that kind of control. Or maybe you could even make a flow map of the surface and have them move across the flow map. But just doing this with noise, you can't stop them from bumping into each other because you don't know where they are. So there we go. But we have perfectly looped animation using nice little drivers. And we have things sliding around on the surface and lerping in between different shapes as if they have shape keys. Hopefully this was enjoyable. Hopefully it was informative. And I'll catch you in the next one. I'll see you later.